Today we're going to talk about exponential functions. Our objectives include how to evaluate an exponent in a function, how to graph exponents in functions, how to evaluate functions with the base of e, and how to use the compound interest formula. First, let's go ahead and define what an exponential function is. It's basically a function that has a base, and that's what we'll call b, and it has an exponent. Now when you write a function, remember it can be in function notation, which means they use the f of x in the notation, or you can just use the letter y, and that will denote the same thing. Basically, f of x and y can always be interchanged. Now let's review some exponent rules that you know. If you ever have a base raised to the 0 power, that's called the zero exponent rule. And you've probably learned before that that always gives you an answer of 1. If you have any base raised to the first power, then of course anything raised to the first power is equal to itself. So that would be b. And last but not least, remember that when you have negative exponents, they will always flip the base. That means they take the reciprocal. So b over b to the negative 1 power equals 1 over b. So remember these 3 rules as you work through today's exercise. Now, let's look at a couple of homework problems. First off, we'll go ahead and look at homework number 1, which is base of 8 raised to an exponent of the square root of 5. A problem such as this needs to be worked on the calculator. Let me go ahead and give you another example that's just a bit easier than this one, and that would be base 8 raised to just the number 5. On the TI 30X calculator like we have in the classroom, you would type into the calculator the following steps. You would type in the 8, and then you would hit the exponent key, which looks like an up arrow or a caret editing symbol. Then you would type in the exponent 5, and you would hit the equal sign, which may also say enter on your calculator. Whenever you put in 8 raised to the 5th exponent, you will get the answer 32,768. Now the only thing different with this example is that we have square root of 5 given. So what we will do is we will, in the calculator, put in the base of 8. Then we will also click on or hit that exponent key. But instead of just putting 5, we will need to put the square root of 5. Now again, on the TI 30X calculators that we have in the classroom, you would need to type the second function key, which is a blue key, in the upper left corner. And then you would need to hit this key, which is x squared, because in blue right above it, it has the radical symbol. And then you would type in the 5 and then the enter or equals. So let's go ahead and try that. Base is 8, exponent key, second function, and then of course the square root radical symbol, the number 5, and then enter. You will round this off to however many places are given in the homework directions. If I round it off to 3 places, that would be 104.561. Now in homework number 3, you're actually given a function's rule. It is f of x equals base 7 with a negative x exponent. And you are asked to find 2 values, f of 0 and f of 2. To find those values, you will simply substitute in the number given in place of the x. So notice where the x was, I will now substitute in a 0. Now 7 to the negative 0 is the same thing as just 7 to the 0. And we just looked at that. Anytime you have a 0 exponent, the answer is always 1. Now when you need to use 2 in this particular function, you will have 7 and you will put -2. Again, the x value becomes a 2. The negative was already there in the function. And 7 exponent -2 will flip the 7, so that will be 1 over 7 squared. When the base takes the reciprocal, or when it flips, that becomes positive. And 7 squared is 49, so my final answer is 1 over 49. Now, how do we go about graphing a problem that has exponents in, like here? First, I would need to set up a table, and I normally recommend 5 values to get a good picture of what's going on. Go ahead and use the numbers 2, 1, 0, -1, and -2 to give you some test points for how this graph will look. Then we will substitute in the 2 for the x value. 3 squared is 9. So that means 2, 9 is a point on my graph. Substitute in a 1. 3 to the first is 3, so that means 1, 3 is a point on my graph. Substitute in the 0. Anything to the 0 power is 1. So 0, 1 is a point on this graph. Substitute in -1. That will flip the 3 or take the reciprocal of it. That becomes 1/3. And -1, 1/3 is a point on this graph. Last but not least, substitute in the -2. That will flip the base of 3, and it will be 1 over 3 squared, which is 1 over 9. So the point -2, 1 over 9 is on this graph. Now every time you graph an exponential function, it will be a smooth, continuous curve. It will look like it's going to cross the x-axis, but it never does. The x-axis will be a boundary to this graph, and we call that x-axis the asymptote, which means boundary line. Now let's go ahead and plot some numbers. I have 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 2, 9, which would be right here. I have 1 with 3, which would be right there. 0, 1 is right there. Now when you get to these fractional values, you're just going to have to estimate as close as you can. Make those points appear to hover over the x-axis, because this graph, even though it's smooth and continuous, it will not cross that x-axis. So the curve looks like this. It is an increasing function from -infinity to +infinity. Also, the domain is from -infinity to +infinity. Now another interesting topic when you talk about exponents is the natural base number of e. E is actually called Euler's number. It's named after the mathematician that discovered this. E is the constant of natural and continuous change, and E is on your calculator. If you put e to the first in your calculator, you'll get approximately 2.72 if you round it off. And this is a number that we'll use a lot when we talk about a natural base, or if we're talking about the changes in nature, or the changes in population growth or decay. Now, how do you evaluate something with the base of e? You will use the calculator for this as well. And in the TI 30X calculator, like in the classroom, we would need to type in the e first. Now, to get to e, you would actually type the second function key and then a key that has the letters LN. Now, we'll talk about more of that later, but that stands for natural logarithm, or the logarithm of nature. And since this is a natural base, you will notice right above the ln key on the calculator, it has e to the x. So that's what we need. And our exponent is a 3, so we would type a 3 and then the equal sign or the enter key. So second, and then ln gives us the Euler's number e. Type in exponent 3, and then that will equal 20.086 if you round it off 3 places behind the decimal. Now, last but certainly not least, we're going to talk about compound interest. This is one of the most important formulas or important uses of an exponent function that I think we have, because everyone is faced with compound interest, whether you buy a house or buy a car, or whether you're going to try to invest some money. Now, each of the letters in this formula stand for something. The A stands for the accumulated amount. The accumulated amount means the principal, or what you started with, plus the interest. Most of the time your answer will be the A. P stands for principal. Principal is the starting amount of money. So if you're going to buy a car for $20,000, that would be your principal. The R is the interest rate. Now, the interest rate is always given as a percentage, but you need to remember to change that number to a decimal. T stands for time in years. And last but certainly not least would be these 2 letters, both are N. N stands for the number of compounding periods in a year. That means, is your money going to be compounded once a year, twice a year, maybe 4 times a year? That depends on the wording that is used. Let's look at an example problem. Here we go. A sum of $10,000 is invested at an annual rate of 8%. Find the balance in the account after 5 years, subject to quarterly compounding. $10,000 is the money that you started with, so that will be the P. Whatever the percentage is automatically the R. But remember, that has to be a decimal. So we move our decimal over 2 places, and the R would be 0.08. Whatever the years would be, that is my T. So I would have 5 years. Now there will be a word or phrase that gives you the value for N. The value for N comes from this phrase, quarterly compounding. How many quarters of time are in a year? That would be 4. So for the N, you will actually use 4. Now let's substitute this value, or all of these values, into the formula. All right, P is my principal, 10,000. Rate is 0.08. Then that's divided by 4. And then my exponent would be 4 times 5. Or if you want to make it a little bit easier, you could multiply that 4 and 5. So that would be 10,000 times 1 plus. You could also take 0.08 and divide by 4 in your calculator, and that will give you 0.02 when you divide to the 20th power. So you could simplify that fraction and that multiplication. Now you will simply type this into your calculator. So 10,000, open parentheses, 1 plus 0.02, close parentheses. Then you will hit the exponent key because our exponent is a 20. And you will type in that 20 for the exponent and hit equals. The answer here is 14859.47. That stands for $14,859.47. That would be your answer, or your A, which is also accumulated amount. Now be very careful when choosing the compounding periods in. The words that are normally used are annually, and that would be n equals 1. Semi or biannual, n equals 2. Quarterly, that we've just seen, would be n equals 4. Monthly, n equals 12. And daily would be n equals 365. Good luck with this homework set of exponential functions.